आज ही डाउटनट ऐप डाउनलोड करें। डाउटनट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Friends, here we are given with the question, let ABC and M belongs to R positive, that is positive real number. The possible value of M independent of ABC for which at least one of the following equations have real roots. Okay, so here three quadratic equations are given. Fine, so we have to find the value of M such that any of the three quadratic equations have real roots. Fine, so we know that for having the real roots there is a condition, that is D should be greater than or equal to 0. What is D here? D is nothing but discriminant. So let's say we represent the general quadratic equation as ax square plus bx plus c equals to 0. For this quadratic equation we have D as b square minus 4ac. We know this. Fine. So can we say that for these three quadratic equations, if d1 plus d2 plus d3 is greater than or equals to 0, then there will be one equation, at least one of the quadratic equation which will have real roots. Why? Because the sum of three numbers can only be positive if at least one of them is positive. That means at least d1, d2 or d3, any one of them should be positive. Otherwise this inequality will not hold. Fine. So that means one of the quadratic equation will have real roots. Fine. So now putting the values of D, we can write here D is nothing but b square minus 4 times a and constant term which is cm. Similarly for d2, here we have coefficient of x which is c square minus 4 into a which is coefficient of x b here, coefficient of x square is b here, and constant term is am. And then a square minus 4 times coefficient of x square which is c and constant term bm greater than or equals to 0. We can rearrange this. We can write a square plus b square plus c square minus 4 acm minus 4 bam minus 4 cbm. Fine, greater than or equals to 0. Now taking this to other side and taking 4m common, we have let's write a square plus b square plus c square is greater than or equals to, let's take 4m common here, ac plus ab plus bc. Fine. Now since this we know that a, b, c belongs to R positive, so we can simply divide this on the left side because inequality will not change. Why? Because all numbers are positive. Fine. So we can write here a square plus b square plus c square upon ab plus bc plus ca is greater than or equals to 4m. Fine. So we can write this as our equation 1. Okay, now we know that a minus b ka whole square will always be greater than or equals to 0. Why? Because an square of any number can be positive or 0, right? So this inequality we already know. So opening this, we can write as a square plus b square greater than or equals to 2ab, right? We can write this. Okay. Similarly, we can write b minus c ka whole square. So we can similarly extend it to for b and c. We can write b square plus c square greater than or equals to 2bc, and similarly we can write c square plus a square greater than or equals to 2ca. Fine. So adding all these, since these are all we know that we can add the inequalities if the inequalities are same. So adding all, we can get 2a square plus b square plus c square is greater than or equals to 2 times ab plus bc plus ca. Fine. So since we have assuming, okay, let's assume since here a, b, c are positive, so we can simply divide it and cancel the 2. So we will get a square plus b square plus c square upon ab plus bc plus ca is greater than or equals to 1 for this for abc positive. For abc, fine. Okay, now this is our equation 2. Fine. So this was our equation 1 and this is our equation 2. Fine. This is our equation 1. Fine. So now we can also write this first equation as let's write a square plus b square plus c square upon ab plus bc plus ca minus 4m. We can write as minus also, right? We can simply make this 4m this side, okay? So it will become minus 4m, fine. So we know that here in this inequality, as you can see, that the minimum value of this term will be 1, right? So in this equation we will put the minimum term of this value. Why? Because let's say you can let me explain here. So suppose a is greater than or equals to b, and suppose here a varies from 1 to infinity, fine. So you know that this is greater than or equals to 1. That means this value can be from 1 to infinity, right? So let's say this a varies from 1 to infinity. So when will this inequality hold? For which value of b this inequality should hold? Fine. So what you can say, if suppose b is 1, then this inequality will always hold. Why? Because a can be 1, 2, 3 or like that, and b is 1, so a will be always greater, right? But if let's say b is 2, then a can be 1 also, right? That means this 1 is not greater than equals to 2, right? So that means b will this inequality will not hold for b2. That means this inequality will only hold for minimum value of a, right? So we will take the minimum value of this expression, which is 1, right? So we can write here 1 minus 4m should be greater than or equals to 0. Then we can take 4m this side. It will become 1 greater than or equals to 4m. M is less than or equals to 1 by 4, fine. So now just a second. Now this is given that m is here m is less than or equals to 1 by 4, right? That means m is less than 1 by 4, that is minus infinity to 1 by 4. But it is given in the question that m is r positive, belongs to r positive, that is positive real number. That means m belongs to 0 to 1 by 4, fine. Here 1 by 4 will be included. Why? Because there is a equality sign over here, right? So this is our answer, fine. Thank you. So here option 4, which is 1 by 4, is correct, fine. थैंक यू।
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।